Lesson 4. How to write a discussion part of a chemistry lab report. This section is the most demanding part to write. It requires you to prudently think about the results you obtain during the experimental sessions, and relate them to the objectives of the experiment. Besides, it calls for the interpretation and generalization of the results. Therefore, students should relate the experimental results to the scientific knowledge under investigation and the objectives. In some chemistry lab reports, especially short lab reports, discussion and conclusion are included in one section. However, in long chemistry lab reports, the discussion and conclusion have their distinctive sections. Let us consider the results, examples 1 and 2, of the lab report in the previous lesson, Lesson 3, to help us write the discussion part of the chemistry lab report. Discussion of Example 1. Sodium hydroxide acetic acid titration curve has a lower initial pH and higher equivalence point as compared to aqueous ammonia hydrochloric acid titration curve. Figure 1 and Figure 2. The pH of the NaOH-CH3COOH titration curve increases from its initial pH as it approaches the equivalence point. On the other hand, NH3HCl titration curve decreases from its initial pH as it approaches the equivalence point. NaOH-CH3COOH and NH3HCl titration curves tend to follow the same pattern after the equivalence point. Figure 1 and Figure 2. The pH of the NaOH-CH3COOH titration curve increases after equivalence point and then remains constant. Furthermore, the pH of the NH3HCl titration curve decreases after equivalence point and then remains constant. NaOH-CH3COOH and NH3HCl titration curves do not start at 0 points along x-axis and y-axis. Figure 2 along x-axis shows that more volume of HCl was used to attain equivalence point, while Figure 1 along x-axis indicates that less volume of NaOH used to achieve equivalence point. The experimental pKa value of acetic acid 4.3 is less than its accepted pKa value 4.7, though the experimental Ca value of acetic acid 5.012 by 10 to 5 is greater than its accepted Ca value 1.8 by 10 to 5. The percentage error between pKa values of acetic is small, 10.23%, while its percentage error for Ca values is large, 64.09%. Additionally, the experimental pKb 9.57 value of aqueous is larger than its accepted pKb value 4.75. Nonetheless, its experimental Kb value 2.692 by 10 to 10 is less than its accepted Kb value 1.76x 10 to 5. Moreover, the percentage error between the pKb values of aqueous ammonia is moderate, 50.37%, but its percentage error between Kb values is extremely high, more than 100%. Therefore, contaminated apparatus, acetic acid and sodium hydroxide, aqueous ammonia used might have led to experimental errors. These negatively affected the experimental results. However, the objectives of the experiment were achieved. NaOH-CH3COOH monitoring titration was more helpful than NH3HCl monitoring titration because there were limited experimental errors as in NH3HCl monitoring titration. Discussion of Example 2. In Figure 1 and Table 1, there are peaks at about 3,000 cm-1, 1,350 cm-1 and 1,714 cm-1. These imply that there were a CH stretch, CH bend, and C equals O stretch. Therefore, these peaks best describe an aliphatic ketone. Hence, 2-pentanone was the possible identification of unknown organic solution number 1 among the list of organic compounds present. Organic compounds such as ethyl benzoate, aniline, benzoic anhydride, benzaldehyde are aromatic organic compounds, thus they have different IR characteristics as compared to aliphatic organic compounds. For that reason, their IR properties ruled them out as possible candidates for unknown organic solution number 1. Additionally, IR vibrational stretches and bends of an alkyl alcohol, acetamide, and propanoic acid are not the same as those of aliphatic ketones. For instance, if propanoic acid was present, then the C=O vibrational stretch peak could have appeared between 1760 cm-1 and 1690 cm-1. Moreover, OH stretch, CO, and OH bend could have occurred at between 3000 cm-1 and 2500 cm-1, and 1320 cm-1 and 1210 cm-1, and 1440 cm-1 and 1395 cm-1. However, these are absent in figure. Furthermore, if acetamide and alcohol, we could have seen peaks between 3,500 cm-1 and 3,200 cm-1, and also 1,550 cm-1 and 1,475 cm-1. Though these are absent in Figure 1, making 2-pentanone as the best organic compound represented by unknown organic solution number 1. In Figure 2 in Table 1, peaks appeared at 1,714 cm-1, 1269 cm-1, 3,000 cm-1, 1,980 cm-1, 1,600 cm-1, and 1,400 cm-1. The peaks indicate that there was the presence of C=O stretch, CO stretch, CH stretch, a weak overtone, and CC stretch in ring. These peaks aptly define aromatic compounds. Therefore, an unknown organic solution number 2 did not represent acetamide, alkyl alcohol, propanoic acid, and 2-pentanone. Besides, the presence of the peaks for C=O stretch and CO stretch, which describe ester, lock out the benzaldehyde, aniline, and benzoic anhydride as the representatives of the unknown organic solution number 2. The peak of AC=O stretch of the ester occurs between 1730 cm-1 and 1715 cm1, while its peak for CO stretch appears between 1300 cm-1 and 1000 cm-1. The experimental peaks for C=O and CO of unknown organic solution number 2, Table 1 and Figure 2, were within the range of the peaks in the literature of C=O stretch and CO stretches of an ester. Smith, C. 2007, 43. So, this qualifies ethyl benzoate as the representative of unknown organic solution number 2. The experimental peak values for both unknown organic solutions number 1 and number 2 were almost the same as the peak values in the literature of 2-pentanone and ethyl benzoate. Hence, the experimental errors, which might have originated from contaminated unknown solutions and the sample cell, and improper handling of IR spectrometer, had insignificant effects on the experimental results. For that reason, the experimental results had high precision, though, for one to achieve better results in the future, one should use industrial-grade reagents. Moreover, sample cells should be properly cleaned with an appropriate solution, and an IR spectrometer should be operated as enshrined in its operational manual. The aims of the experiment were achieved. B. Unknown solutions number 1 and 2 were identified using the IR spectra generated by a variant 640 IR. In addition, the experimental results were within the range of similar studies conducted before. As a consequence, this implies that the objectives of the experiment were justified. In literature, Peaks of C equals O stretch for aliphatic ketone appears at 1715 centimeters minus 1, Smith, 2007. On the other hand, peaks of C equals O stretch for C equals O and CO stretch for unsaturated esters exist at 1730 to 1715 centimeters minus 1, and 1300 to 1000 centimeters minus 1, figure 2. In this experiment, the peaks of C equals O stretch and CO stretch were 1714 centimeters minus 1 and 1269 centimeters minus 1. Consequently, they are in agreement with the peaks of C equals O and CO for ketones and unsaturated esters in literature. Final remarks. In the examples above, the results of Lesson 3 are carefully explained in relation to the scientific knowledge under investigation and the objectives of the experiment. In both examples, the conclusion part is not included.